This video will introduce standard normal calculations, otherwise known as the z-score, and how we standardize things with different mu's and standard deviations. Your pages to read are pages 93 through 102. And let's begin. The vocabulary that we're going to need in this particular video, we're going to talk about normal distributions, which you've already seen, the empirical rule, which is most of the time known as the 68, 95, 99.7 rule, standardized value, which is our z-score, the z-score itself, standard normal curve. What is that? Whenever we talk about a standard normal curve, you have to understand what it looks like, and then a normal proportion. Okay, as the 68, 95, 99.7 rule implies, all normal distributions have properties that are in common. But how do you compare normal distributions that have different mu's and or standard deviations, such as when we talked about the normal height, the average height of a woman in the United States is 64.5 inches, and the average height of a man is 69 inches. How do we compare those together? The standard deviations are the same in this particular case, but we can even compare things with different standard deviations. And the answer to that is to change their units to something that we can plot on the same curve, and we call that standardizing or creating a standard normal curve. The z-score that we're going to learn how to calculate and to find today tells us how many standard deviations away from the mean that particular value is. So now we can compare overall standard deviations. So if what we consider someone to be a very tall man may not be as far as many standard deviations away from the mean as a woman who is well above her average height. So the way that we're going to calculate that is finding the standardized value, or z-score, and what you see in front of you is the z-score formula. This formula will be your best friend for the rest of the year. We'll see this in many different ways that are used to explain how far away certain values are. So throughout the whole year, we'll use this using means, the standard deviations, and proportions. And so this formula should be very familiar to you, and you should make sure that you memorize it. The example that we have right here, this is example 2.4 from your book. It says the heights of young women are approximately normal. Okay, so as soon as you see that, you know it's a normal curve. Mu 64.5 inches, standard deviation 2.5 inches. The standard height is given by z equals the height, and the height is whatever individual value that we are looking for that particular person, or that we're given that, and we're going to find the z-score, how many standard deviations away that person is. So it's the height minus 64.5, which is our mu, over the standard deviation 2.5. Okay, and whenever we're looking at a woman who is 68 inches tall, for example, then that z-score is going to come out to 1.4. In the front of your book, you have an A table. You will also be given one to keep in your notes. 1.4 will be found in the left-hand column, and since there's not another digit, we would assume that it's 1.40. And so we will always look in our A table for one ones place and a tens place and a hundredths place. So in this particular case, it's 1.40. That percent is 0.9192. Now we have to be very careful. Did they ask if what was the percent that was that tall or less, or that tall or more, or greater than or less than? So we have to be very careful with the wording of the problem. In this particular case, a woman that's 68 inches tall would be taller than 91.92% of the population. Once we've found the z-scores, the standardized values for all of our x's, then we can graph them on a standard normal curve. And we notice the notation that in the first line of this particular definition, that they use n and then parentheses 0, 1. In a standard normal curve, in the middle is always 0. We've basically zeroed out what we're looking for. We're starting from scratch, and we're only comparing how far away something is based on the standard deviations, not the mean, not the standard deviation that was given in the problem, but the z-score, the standard deviations away. So if that person falls 1.5 standard deviations above the mean, or two standard deviations below the mean, then that is our z-score. This allows us to quickly compare normal distributions in different mu's and standard deviations. So table A, that's the standard normal probability table, we'll just call it table A, only finds the area to the left. So we have to be very careful. If you're looking for a probability that's more than, greater than, or at least, you'll need to subtract that value from 1. Why 1? Because underneath the curve is 100% or 1 of our population or our sample that we seem to be measuring. So look at this next example. Find the proportion of observations from the standard normal distribution that are greater than negative 2.15. Well, it's greater than negative 2.15. So whatever we find in our A table, we have to subtract that from 1 to get the area above it. And you should always shade the area that they're asking for, that the problem is requesting. In this particular problem, they have the area shaded to the left, but we're actually looking for the area to the right. So I disagree with the way that this example is set up. We should always shade it to the right if we're looking for greater than or more than. But when we look at our table entry, we notice that we're looking at negative 2.15, and we see negative 2.15. We go all the way over, and that value is 0.0158. So if the problem requested how much is less or fewer than, then that would be our answer. But since it's greater than, we're going to have to subtract it from 1, and we get 0.9842. So 98.42%. Okay, and that's coming from the A table. Practice looking at the A table. The first two digits are here on the left, and then the last digit is always, we find it by looking across the top. So it's 0.0158 in this case. Okay, so the next example, what proportion of all young women are less than 68 inches tall? Okay, so 68, it's less than, so we know that we're going to be looking to the left. That's exactly what our table gives us, so we don't have to subtract this from 1. When we plug it into our z-score, we get 1.4. This is what a normal distribution looks like. See the normal curve, see it's at 68 and it's shaded all the way back to the left. Okay, at 1.4 standard deviations above the mean, oh look, it looked very much like the curve that we just saw. It's 1.4 above, 1.4 standard deviations above the mean. In this particular case, since we've standardized it, it's 1.4 standard deviations above 0. Look back, 68 is 1.4 standard deviations above 64.5. Okay, and so it's to the left, so our area is 91.92% of all young women are less than 68 inches tall. Okay, we're finding normal proportions. These 4 steps are a guide to make sure that you don't miss anything and that you shade it the right way and that you look up the right numbers. So please refer to this guide. It's also in your book as your procedures for finding normal proportions. Thank you, and I hope you've enjoyed this slideshow.